I should put up my next section slide, but I didn't. Okay, so let's go on to our main topic for today, or our last topic for today, and that's file input and output. So I have a file here, abc.txt, and abc.txt has 3 lines, A, B, and C. Let's type another line. We'll put some more stuff in there just to make it, just so you see a little better that it's not just reading one character. So we can, if we want to read that file, right, that file exists in come on up. In my directory, in my Lecture13 directory, right, there's abc.txt. I can open it into something else. It's just a file. It's just a text file. And I generated it here. So now we can come in here and we can start playing with it. If I want to read from that file, the first thing I have to do is I have to open it. And that is not opening it. I'll just type it. It's easier. Okay, when you're in the correct directory, right, if you get that error, that just means you weren't in the right directory. As you learn more about directory structures, you'll figure out that you can put in additional text in here to tell it to go look in a different directory. But for right now, we're just going to assume that things are in the directory we're actually executing in. So we can now open up f equals open abc.txt, and that tells us that we can now start reading the file. This is actually a shortened form of that, where the R stands for, the comma R is I want to read. R stands for read mode. So if you're reading, you don't need that. If you're writing or appending, you do actually need that. And there's a number of ways to read things from a file. The easiest way, or the way that I like to do it, is using the read line. And the reason I like read line is we're often going to ask you to take input one line at a time. And if you use a read line and a loop, then you never have to do your splits on n, and you don't end up with any of those issues that we saw up above about extra R's and /T's and stuff like that. You get it in one line at a time. You get it in up to and including the /n. And if you do something simple like line equals line.strip right now, or even line.rstrip, now what you're left with is the characters on the line with no /n's, etc. However, if you like to do more work, you can also do something called a read. And f.read just reads from the current place in the buffer. Now remember that we did a read line, so we read a/n. Everything left is B, C, and this garbage string that I put in there. So if we do an f.read, we get back all the rest of the stuff. B/n, C/n, and then that last line that I put in there, it all comes in together, and every place that I hit a carriage return, we get a /n, and if I were to put another carriage return in there by doing that, and run it again, right, now we get another /n out there because that's, well, what we actually have, right? And okay, once we get to this point, once you've read everything in the file, any subsequent reads are going to give back the empty string, and any subsequent read line will also give back the empty string. So once you get to the end, you'll start getting back empty strings. If we want to process a file or process every line in a file, we can do something like this, right? We do our open, we open the file, and then we do for line in the file, print line. So this will take line, it'll set it to every line that's read in the file, and then in this particular case, we'll print it out, although that print could be, whatever you actually want it to be. One thing to notice is that print always puts a /n at the end of a line. These lines all have /n's at the end of them. So when we do our read and then print, we end up with a/n puts us down here, and then print puts another /n, and we end up with an extra blank line in between all of our lines in our file because there's already a /n in there, and then we put another one in with the print. If we don't want to do that, we can come through and do something like comma and equals the empty string. That'll take care of it. Or we could do something like line equals line.rstrip. Now, in this case here, we have to be careful that there aren't significant other white space characters that if this was a space, and we wanted to preserve the 3 spaces, we couldn't actually do this one. We would have to be very careful. Okay. This is an explicit way of doing it. Every step is explicit. Every step is shown. But you can also do it with a little bit of a shorthand where you kind of combine the open into the same, right? In this one, we did the open separately. We assigned it to F, and then we did for line in F. Well, we can just take F out of the equation completely and put the open down here right on the line itself. That's what this shows. And that'll pretty much just do, identically the same thing. Whichever way you're most familiar with, or whichever way you're most comfortable with. All right. Did you have a question? There was the person had a question. Does that?
Yes. On the lecture exercise, when we put it in SMITI, if we write it as a basic text file in Notepad, it, despite being identical in terms of output from student and output expected, SMITI gives a grade of 0 because there are apparently inexplicable return characters that cannot be removed. Is there any way to resolve that?
Yes. The way the SMITI output should be correct. It matched my output. So that's maybe not much, you're talking about part 1?
Yes.
Yeah. So I think you're missing one more blank line at the end of after line 4. If you put it in just like this and you didn't hit return after line 4.
No, it matches exactly. The only difference is when you hit visualize white space characters.
Yes, this is a test of white space characters. So that's exactly what should be shown.
Even though there is a blank line 8.
Yes.
Okay.
Okay. All right. So continuing on. If you want to open a file and then read from it, right, we get the first line back. We can also come back in here and we can now close the file. And closing isn't as important when we're reading unless we want to start over again, because if we do open again and now read it again, we get back to the start. So every time you open, you end up at the start. Close is a way to close the file, clean things up for being, so you can start over again. It's always a good practice to close your files because you only are allowed so many open files at a time. It's a pretty high number though, so it's not likely that you'll hit it. But when you're done using a file, please close it. It's not as important when you're reading from it. It is still important. You'll still get dinged for it in some instances in our grading because we want you closing your files. Or maybe that's when I did it in operating systems. Anyway, but it's really important when you start doing writing, which we'll get to in just a minute. Okay, let's open up another file here for a second. Let's look at our scores file. We have a list of scores. And let's say that we have a sequence of integers representing test scores, 1 score per line, and we want to write a program that computes the average of those scores. Right, so we can start off, right, we'll just get in a file name equals input file name. Give ourselves a little bit more room. Colon. Okay. If we're on submitting, we're going to want to do a print file name. And if you're following along in the text, you'll find you already know that I'm skipping something. Let's look at num scores. We'll say that that's the number of scores we've read in. We'll set that equal to 0. We'll say the sum scores, that's the total. We'll set that equal to 0. And now we can say for S will be the individual score we're going to read. And we'll do it for in open file name. We'll add whatever we read on. We read some scores plus equals int s.strip. The strip isn't strictly necessary, but it's kind of good form. And then num scores, in case there's garbage on the end. I think the int conversion function would probably drop that, but anyway. So now we're going to commute, right? We're accumulating the scores into our sum scores variable. We're accumulating the number of scores into our num scores, sum scores and num scores, sum skulls and num skulls. And now we can come out here, and I'm just going to steal this line, assuming the cut and paste works. There we go. And then we just print out the sum divided by the number, and that should actually work. And if we save this and run it, and we put in scores.txt, we actually get a value. Wow, that's not good. 66.6. We should be more careful about the numbers we choose. Right, so it actually works. But what happens if we start doing something stupid? Like, let's say I put a couple of blank spaces in there and then do scores.txt. Oh. And let's try actually spelling it correctly. Right. Well, it turns out that in this case, those spaces are actually important because it's trying to open a file name with spaces in it. And while you can't really create it so well from your command line, you can actually have file names with spaces in if you make a mistake. So, so we want to make sure we do when we're reading, anytime we're reading in a file name or a string where, you know, even a person's name, any string where we actually want spaces, leading and trailing spaces to be ignored, is we want to make sure that we come in and we want to do, I like to put it right here. No, we can't put it right there because we're going to print it out for submitting. We want to say something like file name after the print file name. We want to say file name equals file name dot strip. And make sure you put it after, right? Because we want you to put out exactly what submittee got as input. That'll help you when you're doing your debugging, and it's going to be necessary in order to match the submittee output. And sometimes we are testing how you handle leading and trailing spaces. So if we do this, and we hit this again, and now it doesn't matter how many I put out there, as long as I put in scores.text, we'll actually get the correct value. And you can see we have a bunch of leading spaces here. Okay, so make sure, it's always good when you take input from the user, particularly on file names, but pretty much on any string. It's less important on floating point and integer numbers, although, in general, it's good form to do a strip there as well. Use a strip to get rid of any of these leading and trailing spaces that could kind of be breaking up, could result in an error when you come down here and try to open the file name. Somebody hitting return or hitting the space before they type in the name is not all that unusual, particularly if you don't have if your output looks a little weird. So just be careful, kind of take care of that. I like this. We're going to talk about getting the file name. Well, that's this, right? We're going to talk about the importance of using strip. That was most of the rest of the things we talked about, and then the rest of the program. Well, it's not really much of a program. It's really pretty short. You guys should be able to follow everything except maybe the I/O. All right. We can do the same thing to write to a file. Let's say instead of reading in this file, just reading in this file, we want to write out something. Well, actually, let's start a little easier. If we have an output file, we open it the same way. String file name. And then instead of an R mode or a blank, we want to put a W for a write there. There's also an append mode, which will add on to the bottom of the file. We don't tend to use that as much, but you should know about it. You should know it's there. If you're building up a log file, for example, if you want to log all the errors from your program, you're going to want to use an append. You don't want to overwrite the file when you read it. But we can open a file. We can now do an fout.write. Right, fout is the file we opened. The write is the write, apparently. And we can do something like.
But should it be F_out, or am I bugging?
No, you're right.
Okay.
My fingers are getting tied up in knots right now. We can write something. Hello file. That should probably be a string. Right, and the 10 comes back to tell us that it wrote 10 characters. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So we know the file is there. We know we wrote 10 characters. If I come into here, into my handy dandy everything folder, we can come down here and we can see our beautiful friend out file, and we can open it up and we can see that it is absolutely completely blank. Remember we talked about that buffering? In order to ensure that what you did gets thrown out to the file, you have to do an fout.flush. That'll do it. Right? Hello file. It's now there. Oh, you guys can't see it. Hello file is now there. If we do it again, okay, this time we write out 16 characters. It's still not there. If we were predictable, we would do another flush. But the other way to ensure that something gets flushed is to do a close. So we can do an fout.close, and that should also flush this out. Of course, it's not rereading from the file, so let me just pull it up again. Okay, so now it's there again. One thing to notice is that unlike when we print, when we use the write, right, it told us it printed out 10 characters. Well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Hello file, the first time we wrote it printed out 10 characters. Well, that's exactly how many characters are in hello file. It didn't write out any /n's like the print would. We actually have to write that out ourselves if we want to do it. I told you there was an append. Let's use the append for one just to show you how that works. We can open up the out file. We'll open it up in append mode. And now we will write fout. I got to stop using underscores and things. And we'll just throw in some /n's and a new line. Or a new lin. It'll be a new lin. Appropriately new lined. And we can close it again and see what that does for us. And okay, so, well, you can't see that yet. Ta-da, the great unveiling. So again, now we put a new line in there, and then we did our new lin, and then we did another new line, and then we did appropriately new lin, and then you can see that anything else will come out down here. So the append just adds on, it added on from this new line all the way down to, well, this new line at the end. All right. If we were to open this again in write mode, instead of A mode, instead of append mode, it would actually, well, wipe out the file. Right, so now the file is empty again. So write mode starts from a blank file. If the file's there, it deletes everything in it. Append starts from the previous file and allows you to add on to it. Okay, and it's really important when you're writing files to close, because close actually does the flush and makes sure that everything's settled on disk. Flush will also work, but it's, again, bad form to not close a file, particularly a file you're writing to after you're done with it. So always use close. When you're done writing, if you want to flush intermediate times, you can use the flush command. I don't even think we have the flush command in this lecture because we want you to close. Anything else? Right, take any string. So if you actually use format, you can format your string. You can include your /n's however you want, and then whatever that single string is will get printed out. And you can use concatenation. What you can't do is something like you can't come in here and say comma A. Right? Write takes exactly one argument. It doesn't do that concatenation for you automatically. You could come in and use the concatenation operator, though. That'll generate a single string. Okay? All right. We've got, what, about 5 minutes? Yeah, let's do a quick tour of this. I'm not sure how much we'll get through, but I'm gonna lie. I don't know why I keep these in here, because I never have time to actually do them. This was from our first lecture, right? We had import URL lib request. That just gives us a URL library set of functionality. We then set up this word URL to go to a specific website. And if we pop this in, you know, this website just essentially contains a bunch of words. So these lines essentially right? This sets up a URL. This is just a string. You should think of this as the file name. This is where to go to get your words. This opens it up, right? So you have a URL open that's akin to your file open. Instead of taking a file name, it takes this URL. Now, once we've done this, we can operate on Word file just like it was a file to read from, right? And by the way, this is right, here's the /r/n, right? That's the stuff we're running into, right? So we can do a strip on that, get rid of that stuff. And then this B just says it's binary instead of string data. So what is that? .decode. Yeah. Okay. So, at this point, this URL looks just like it was a file. And for static pages, things that exist in like an HTML file, this will just read one line at a time from the page. And this is how we got the words we used to go through in our initial example and look for the ones that had triple double letters, right? So this just looks like just looks like a file. It is just a file, but it's a file on the web. You'll have some slower access, but other than that, it pretty much looks exactly the same. You can use the same operations on it. You just basically we could do a read instead of a read line. Oops. Except I tried to read too many. And it got mad at me. But that's okay. I prefer read line anyway. That's interesting, though. All right. What else do we have in this section? Okay, so on the wrong page. This doesn't work for dynamic pages. Then there's generally an API you have to use. An API just tells you how the data comes across and what calls to make. I think at this point, what time is it? Yeah, we've got about a minute. I'm not going to get into data formats. I'll hit them briefly on Thursday, but there's not really. This isn't. This is an important topic, but it's not really what the lecture's about. We do want to introduce you to some parsing and what parsing means and some data formats, but that can wait until Thursday, I think. For right now, we're giving you all the data formats you need, so I think we're pretty good. So I think at this point, I'm going to wrap up the lecture. We'll stop the recording. I'll stick around, or actually I'll keep the recording going. I'll stick around for 20 minutes, half an hour, and answer questions if you have them. Otherwise, we'll see you later. You guys are free to go. Enjoy the rest of your day, and